Welcome to lesson 2.6, Prove Statements about Segments and Angles. So even though I didn't write it below the title, the goal for this lesson is to be able to understand a two-column proof and the basic ideas of what a proof is. So a proof in geometry is simply defined as a logical argument that shows a statement is true. So just like in the last lesson where we were applying the properties of equality and writing our justifications for each step, that can be turned into a two-column proof, which we'll look at today. So a two-column proof is a proof that has numbered statements on the left and corresponding reasons on the right that show the argument in a logical order. So they go step by step with the numbered statements on the left and the corresponding reasons on the right. So here it's asking us in example 1 to complete each proof. Now there's a couple things you want to keep in mind when working with proofs. In a proof, we do not take any information for granted. So what I mean by that is if you're getting rid of a negative sign, there has to be a reason for that step or justification. So you would say it's the multiplication property of equality because you're technically multiplying by -1. So not taking information for granted means you always start with your given and you don't skip any steps along the way to your final conclusion. And what I always tell people, because there's many different ways to eventually write out detailed proofs, when you're in doubt, include that step or that justification. So, looking at our first proof, any good proof will always start with giving us some information, most likely a diagram or a scenario, and then the final prove statement. So the given statement is always going to be our first reasoning, and it says given the distance from D to E equals E to F, and E to F equals D to F. So you'll see here in our two columns, statements on the left, reasons on the right, the first numbered statement is our given. So the first reason that goes with it would simply be the given information. Any information that we are given, we assume is true for that scenario. Now, each step along the way, I want to get one step closer to my prove statement. And my prove statement says that segment DF is congruent to segment DE. So each step along the way, I want to get a step closer or make progress from the given toward the prove. So looking at that, our two-column proof here, again, we started step 1, reason 1 is the given. For statement 2, they gave us the reason of the transitive property of equality. Now I know the transitive property of equality is the one that allows me to say if A equals B and B equals C, I can drop B from the middle and A equals C. So in this case, if DE equals EF and EF equals DF, the transitive property allows us to say DE equals DF. So the reasoning was the transitive property of equality. So if DE equals DF, in step 3, they just flipped it and said DF equals DE. If we look back to our last lesson, what allows us to flip what's on opposite sides of the equals is the symmetric property of equality. And then the final step, they stated that segment DF is congruent to segment DE. Well, that is based on the definition of congruent segments, because if we know DF equals DE, then we also know the segment DF is congruent to segment DE based on that definition of congruent segments. So what you'll notice over here for your reasons can be properties. They can be definitions. They can be given information, And as we keep going, you'll realize too, some of our reasons can also be postulates or theorems. So let's look at another two-column proof. So we have our given and our proved statement. The given statement says angle 1 and angle 2 are a linear pair. So I'm looking at this diagram. 1 and 2 are a linear pair. They want us to prove that the measure of angle 1 equals 180 minus the measure of angle 2. So I always start with my given info for my statement. So angle 1 and angle 2 are a linear pair. That reason was given. Then they gave us the next reason, which said the angles in a linear pair are supplementary. So I can simply state that angle 1 and angle 2 are supplementary angles. So because I know they're a linear pair and they make a flat line, I know they're supplementary angles. In step 3, their statement was the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Well, because we've established that they're supplementary angles, we can say they add to equal 180 based on the definition of supplementary angles. And then our last step would be the prove statement. So the measure of angle 1 equals 180 degrees minus the measure of angle 2. And that's from that subtraction property of equality, because from step 3 to 4, they subtracted angle 2 from each side. Now we're going to look at two different theorems, Theorem 2.1 and Theorem 2.2. Theorem 2.1 is the theorem for the congruence of segments, and it breaks down to three properties that make up these congruence of segment theorems. First property is the reflexive property, which says for any segment, so if our segment's AB, segment AB is congruent to itself. The symmetric property is the one that allows us to flip what's on opposite sides of the equal. So in this case, we have a congruent sign. So this would be if segment AB is congruent to segment CD, then segment CD is congruent to segment AB. We're just flipping the opposite sides of the congruent sign. And our transitive property of congruence for segments says if segment AB is congruent to CD and segment CD is congruent to segment EF, then segment AB is congruent to segment EF. So now we have a reflexive property of congruence, a symmetric property of congruence, and a transitive property of congruence. Those ones all apply to segments. We also have those same three properties for angles. So Theorem 2.2 is the congruence of angles, and it again has those three properties. The reflexive property for any angle A is congruent to itself. Symmetric, if angle A is congruent to angle B, then angle B is congruent to angle A. And our last one, the transitive property, if angle A is congruent to angle B and angle B is congruent to angle C, then angle A is congruent to angle C. So in example 2, we're going to apply some of these properties. So it says name the property illustrated by the segment. So in part A, if angle 1 is congruent to angle 2 and angle 2 is congruent to angle 4, then angle 1 is congruent to angle 4 is the transitive property of angle congruence. Segment XY is congruent to itself, segment XY, so that's the reflexive property of segment congruence. If angle CDE is congruent to angle RST, then angle RST is congruent to angle CDE. Flipping what's on opposite sides of the congruent sign is the symmetric property of angle congruence. And then in D, if segment AB is congruent to segment BC, Then segment BC is congruent to AB. That is the symmetric property of segment congruence. And then looking at our final example for our beginnings process of proofs. Example 3 says use the given information in the diagram to prove this statement. So given 2 times the measure of angle ABC equals the measure of angle ABD. They want us to prove that angle ABC is congruent to angle CBD. So we're trying to prove that ABC, this right-hand angle, is congruent to CBD, this one on the left. And we know 2 times ABC equals the whole angle ABD. So first things first, we always start with our given. So just rewriting the given statement, 2 times the measure of angle ABC equals the measure of angle ABD. Reason is given. For step 2, the measure of angle ABC plus the measure of angle CBD equals the measure of ABD. And that's going way back to our angle addition postulate. So again, our reasons, we can use postulates, theorems, properties, definitions. So using the angle addition postulate, that tells us if we have 2 adjacent angles, the 2 added together equal the total. So then I'm going to use the transitive property of equality. If the measure of ABD is equal to 2 times the measure of ABC, I can replace the measure of ABD with 2 times the measure of ABC. So step 3 would say 2 times the measure of angle ABC is equal to the measure of angle ABC plus the measure of angle CBD. And that's the transitive property of equality. Then what I could do is subtract 1 measure of ABC from each side. So if I subtracted a measure of ABC from the left and right, what I'd be left with is the measure of angle ABC equals the measure of angle CBD. So by subtracting this angle measure from each side, I'm left with this statement, and that was using the subtraction property of equality. And then our last step, number 5, is our prove statement. Now that I know the measures are equal, based on the definition of congruent angles, if they have equal measures, the angles are congruent. So angle ABC is congruent to angle CBD by the definition of congruent angles. So this is starting a 2-column proof from scratch, going from the given, and each step along the way using a postulate, a theorem, a definition, a property, that we want to get 1 step closer each step to our final prove statement. Now, the first times that you're working through proofs, identifying the properties aren't too bad based on the examples, but figuring out the order for statements and reasons can get a bit tricky. I would consider learning proofs for the first time just like learning a foreign language for the first time. It's something you're not used to, so just be very careful, take it 1 step at a time. And if you're missing some things in the first few attempts, don't worry about it. Check the selected answers, ask for help, and learn from your mistakes to make sure you're including that information next time.